Hello, welcome to my YouTube channel. Today I am solving one of my Sudoku puzzles. This one is called Poet Himself. The rules are rather lengthy and convoluted. Basically, the rules are talking about the poet Edgar Allan Poe, and I guess I'll just read them. Here are the rules. The poet himself wrote The Raven. Quote the raven nevermore. In this puzzle, the rule is never four. Place digits 1, 2, 3, 5, 6, 7, 8, and 9 in every row, every column, and every 3x3 box. So every row, every column, and every 3x3 box has the digits 1 through 9, without the 4 and with a 0. The poet himself wrote stories of killers who caged their victims behind a brick wall, under a floor, and between a pit and a pendulum. In this puzzle, ordinary killer cage rules apply. These are the killer cages, these outlined areas. And the rules of killer cages are that digits cannot repeat within the cage, or do not repeat within the cage, I should say. And that the sum of the digits in the cage is the clue that's giving it the upper left-hand corner. Like that's a 19, that's an 8, that's another 8. The poet himself wrote The Black Cat. In this puzzle, black dots separate digits in a 1-to-2 ratio, and all black dots are given. So these digits across from black dots are from the digits 1, 2, or 2, 4, or 3, 6, or 4 and 8. And all black dots are given, so nowhere else in the grid do any 1s and 2s lie adjacent, or any 4s and 8s lie adjacent. The poet himself wrote The Cask of Amontillado. In that story, the narrator laid bricks to wall in his victim, and at midnight, quote, there remained but a single stone to be fitted and plastered in. Poet himself is an anagram of Phistomephel, lord of the Sudoku ring. Following the rules of this puzzle listed above should leave a single cell to be fitted and filled in on the Phistomephel ring. To solve this puzzle, fill that cell with its highest remaining candidate. For any puzzlers unfamiliar with the Phistomephel ring, it's this ring around box 5. And the Phistomephel theorem is that those digits are the exact same set of digits as these 16 digits in the corners of the puzzle. There are lots of videos out that describe that, and I've spelled the name in my rule set, so if you want to see more about that, you can do a web search for that. Those are the rules. Please go try the puzzle, and then come on back and watch how I do it, and see if I got all the logical steps logically, and tell me whether you enjoyed the puzzle or found it difficult or easy. So with that, I'm going to start solving the puzzle. Now, this puzzle began as the concept of the puzzle was I was going to make a puzzle and use an anagram of Phistomephel as the title, and that I wanted the puzzle to be where you get to the end and you realize that, oh, this is a Phistomephel puzzle, so I've got to take these cells, and I need to make them all the same. I'm not sure that can be done, and I would love to hear from somebody who has ever managed to do that, how they managed to set a puzzle where you needed to figure out, oh, this is a Phistomephel puzzle in order to get to the end. Because I didn't want to give away that it is a anagram of Phistomephel. I wanted that to be like a surprise realization. As it is, I had to put that into the rule set. So I thought of how am I going to make that a Phistomephel ring? And I thought, well, I could just write out the word Poe, as in Edgar Allan Poe, right here in the puzzle, and I would have a Phistomephel ring with these digits. All but the 1 would be pretty much definable with killer cages. And then I thought, and if I put some other killer cages in, I'll be able to push the corners, limit what could be in the corners. And that was the original concept of this puzzle. I didn't think of Poe originally when I thought of Poet himself, but it's just this puzzle was born out of mixing ideas together, and I'm pleased with the way it came out. It's not as good as I wanted it, but I do enjoy this puzzle, and the way to solve it. I left a digit here in this row that can be easily defined by or easily discerned or deduced from the sums of the other three cages in the row. We have 8, 19, and 13, which is 40, and we know that the digits 0 through 9 sum to 41. That's a secret I only tell my favorite people, but if you're watching this video, you are one of those people. That I'm doing Simon Anthony when I do that, by the way. Go watch Cracking the Cryptic. Watch one of Simon Anthony's puzzles, and when he reveals his secret, which I'm not about to tell you because I'm not at liberty to share it. But the secret in my puzzle is that those digits sum to 41. And so this is a 1. That's the first given digit in this puzzle. And it was a pretty easy digit. On these black dots, because there's no 4 in this puzzle, these can only be 1, 2, or 3, 6. So we know that this is not the 1, 2 pair, this is the 3, 6 pair. We know that this is not the 3, 6 pair, it is the 1, 2 pair, and we know which order it goes in because there's a 1 in that column. That makes this the 3, 6 pair. This has to be the 3, 6 pair because it can't have a 1 because there's already a 1 in the box. This is a 1, 2 pair because it sees the 3, 6 in the column. It can't be a 3 and can't be another 3 or another 6. That makes this the 3, 6. So that we don't know which is which, but we know all the digits on the black dots. This 13 can't be 7 and 6 because there's a 6 in the box. It can't be 9 and 4 because there's no 4 in the puzzle, so it can only be 5 and 8. This 5, there is already a 1, a 2, and a 3 in the box, so this can only be the 0, 5. Now we've got 2 5s in what's called an X-wing, where there's a pair of 5s in these 2 columns, so there's no other 5s in those columns. There's already the 2 5s somewhere in these 2 cages. So that the 5 in this column can't be in that box, and it can't be in the top box. It has to be here. This is now, that's 9, 14, 15. Out of 32 leaves 17. There's only one way to get to 17 in 2 digits, and that's with an 8 and a 9. Digits don't repeat it in the cage, so these are not the same. One is 8 and the other is 9. They are not the same. This digit sees them both. This is a 7. This is the red 8, 9. Is that the red I used? I think so. The blue 8, 9 is somewhere there in that 5, 8, or it's up here. 7 is up here with 0. There's a 2, 9 over here. This 8 without it can't be, can't have a 1. It can't have a 5. It can only be a 6, 0, 2. It's the only way to get to 8 without a 1 and a 5. So this is a 6. That's a 0, 2 pair. That's the 3. That makes that the 6 and that the 3. This 19 is now 3, 7, 9. There's a 6 up here, which means that that's a 6, 0, 2 triple. There's no other way to use a 6 without a, there's no other way to use a 6 in this puzzle to get to 8 than a 602. That means this is not a 0, this is a 7. It's not a 2, it's a 9. This is a 0, this is a 2. And we also have, in this top 3 rows, we have these 3 cells that are all the same. This is called roping, when you have 3 groups of 3 that repeat. That 3, 7, 9 is repeated there, there, and here, so that's a 7, 9 pair. And this 1, 5, 8 is here and here, 1, 5, 8. As you're going to see, there is a lot of roping in this puzzle. We have down here, we have a 14 and a 23 is 37. That leaves 4. There's only one way to get to 4 in this puzzle. That's with the 0, 1, 3. The 23 is a 9, 8, 6 and 7, 5, 2. Makes 14, that's correct. Take the 7 out of there, take the 5 out of there, take the 2 out of the top row. This is a 0, 1, 3. This is the easy way to do it. Double tap them. This is a 6, 8, 9. Double tap, double tap, double tap. Okay, it's been a while since I did this puzzle, since I made it. This 34 has 8 of the 9 digits summing to 34. It is missing a 7. There is no 7 in that cage, because 34 from 41 is 7. The 7 is outside the killer cage, but we need a 7 in the box, so that's a 7. This is a 1, 2. It's the same digit as that one, because this digit cannot repeat anywhere in the cage, so it has to be the one that's outside the cage. The 1, 2, 1, 2. This, by the way, should not have a 1. This should not have a 7. This is not a 2, because this 1, 2 pair. This is not a 5. This is a 5 in the row. Okay, 19. That 19 can be 8, 9, and 2, except not in this puzzle because there's an 8, 9 there. So it's not an 8, 9, 2. Could be a 8, 7, 4 if we had a 4, but we don't. So it could be a 9, 6, 3. And is there anything else it could be? I think it can only be a 9, 6, 3. 9 and 6 makes 15, no, 9, 7, 3. It could be a 9, 7, 3 and nothing else. There is no 4. It can't have a 5. So it can't be 8, 6, 5. Can't be 8, 7, 4. Can't be 9, 6. That's 15. It can't be a 9, 6, 4. Yes, I believe 9, 7, 3 is all this can be. So this is the 8. These are the 9s. I'm going to get rid of those colors because I don't need them now. That makes this a 1, 2, 6. The 1, 2 are separated because they don't have a black dot between them. 6 has to be between those. There's a 7 here. This is a 9. That 7, sees that up the column, makes that a 9. This is the 7. That 7 comes down here because that's 7, these two 7s. Put a 7 down in the lower corner. And now we have 24 plus 8 is 32, and we need 9 to complete the row at 41. So this is the other half of 3 and 6, and there's a 6 in the column. This is the 3, this is the 6, this is the 3. Now we have, again, roping in these bottom 3 rows. So the 2 and 6 go here. Oops, small middle digits. Middle. I don't think you can call them middle corner marks. Pencil marks, that's what they call them. Middle pencil marks. Now, why did I put a 9 there? That's not a 9. It's a 1, 2, 6. This 9 up there goes here. This is the 0, 5, 8. And this is the 2, 1. No, I have the 2 and 6. This is the 0, 5, 8. Again, the 1, 2, 6 have to be separated. The 1 and 2 have to be separated there because there's no black dots. If the 1 and 2 were adjacent, they would have a black dot. This is a 2, 5, 7 triple, making that the 1. The 6, 8, 9 here takes the 8 and 9 out of there. Oh, what did I do? Double tap, double tap. The 6 can't have a 3 next to it without a black dot. Oh, and by the way, there's a 0, 1, 3 there anyway. That can't be the 6 in the column, it's the 2, that's the 0. There's a 6. Take the 0 out of here, makes it a 5 because of the column. Makes that the 1. Makes that 2. That was we already had that. These are not 5s. There's a 0 here, so that's the 8. And that's the 0. That makes that the 5 in the column. We need an 8 in the row. There's no 7 in here. Where to next? This is not the 1. It sees a 1, 2 pair in the row, column, excuse me. This 9 sees into that box, not a 9. This cannot be a 6 because it's next to a 3, 6 pair, and it would either be next to a 6, which is not allowed, or it'd be next to a 3 without a black dot, which is not allowed. This is an 8. These are not 8s. This also is not a 6. This is the 9. This is the 6. 9 goes here by Sudoku with these. Do I have all my 9s? 1, 2, 3. No, not yet. Do I have anything? How about 6s? Nope, not yet. 3s? 1s? 2s? Well, this can't be a 3 because it's next to a 6. This is the 7, and the 9, and the 3. Again, we have roping here, 9, 8, 6. We know that this is the 9. Oh. 7, 3, 0, 1, 3, yeah, okay. Let's try some holding down all the digits again. 3, 3. Well, this is not the 3. It's next to a 6. Do I have all my 7s? You know, 7 here, 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 and here. No problems with that. How are my 2s doing? 2. Okay, there's a 2 in that pair there and there from that 2. Therefore, this is a 2. That's a 2. That's a 7. That's a 5. 7 sees into that box, I think. I should have all my 7s. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my 7s. I'm going to gray those. So remember, I don't have to look at those anymore. What about my 6s now? Nope. And 1s? 1s were like 2s. Have I done my 2s? Here, here, and here. This can't be a 2 because it's next to a 1-2 pair. It either needs a black dot or it would be by itself. That's the 2. And these are the 2s. The 1s go here. Did that get all my 2s? 1, 2, 3, 4, 5, 6, 7, 8, 9. And why don't I have all my 1s? Big number. 1, 1. They're here and here. Can't be next to a 2. They're here. Gray the 1s. Have I got all my 9s? Yeah, that's 9. 8s. 5s. 6s. I keep looking at 6s. 0s. Oh, wait. 0s. Not a 0. There's a 5-8 pair. It sees a 5 in the row. That's the 8. That's the 5. These aren't 5. And up there's a 5-8 pair. These two are a 0 and what, an 8? Yep. 8's in the row. That's a 0. This is an 8, that's an 8. And is that all my 8s? Okay, 1, 2, 3. No, 8s are in those two columns. There's a 5. There's my 5. This is a 0-3 pair. This is a, what, 0-3-6? last digit there, 0. Okay, so do I have a 3 and a 6? Yes, I have a 3 and a 6 that can't be in that column, and they have to be in this box. That means that they have to be separated. This is the 0. That's a 3. That's a 0. That's a 6. That's a 3. That's a 6. That's a 3. This is the 8 because the 0 I placed. That's the 0. That's the 5. How did I do this? This can't be right. I just did it wrong. I broke the last rule. I apologize to those of you who saw me do that. This is a 3-6 pair. This is the 0. That's the 3. This is 6. That's a 3. That's a 6. And that's a 3. Okay. Now we're at the point where you need to consult the final rule, because we've got the Fistula ring all drawn in except for one digit, and it is a 0-5 candidate. And the final rule says, to solve this puzzle, fill that cell with its highest remaining candidate, which is the 5, not the 0. That's the 8. That's the 0. That's the 8. And the 5. And that's the 0. And that should be the solution, which I don't think this one is set to accept a solution that has zeros in it. If you want to check your solution, you can replace the zeros with 4s by just holding down a 0. You select all the zeros, and you can tap the number 4, and it should give you the solution. Looks good as far as I can tell. Anyway, turn those back to zeros, never 4. Anyway, if anybody out there knows how to set a puzzle like this where I could make the person do the Fistula ring without giving it away, that's what they had to do, I appreciate your input on that. I'd love to hear how you did on this puzzle, whether it was easy or hard, or whether you found it fun or ridiculous. Anything, any comments you have, happy to listen to them. And please like and subscribe. Thank you.